Okay, this video is going to cover how to reflect a item over a line that is not one of the axes. So in this problem here, we have reflection over the y equals 2. Now, me personally, I would reflect on where that line is. So if we look here, this is the line y equals 2. And sorry it's so wavy. I'm terrible at drawing lines by freehand. So what we're going to do is we're going to change the y coordinate, and then we're going to add double whatever number our axis equals. So if we take a look at this with the a coordinate as our example, we see that we're leaving the x alone, okay, as our rule says, because we didn't move in the x at all, and that we're reflecting over this axis. So all that's going to change is the y. So in previous, when we reflected over the x-axis, all we changed was the sign of the y-coordinate and we were done. But now we have to add however much we are from the axis. So with a here, we're changing the sign. So we got -4 now. So we have a -4. So we change the sign of our y-coordinate, and we need to add twice whatever the y was, which is 2, which equals 4. So -4 plus 4 ends up being 0, and thus we get 0. Let's try this for b. So b, I changed the y-coordinate sign, so it becomes -1. And once again, I add double whatever the y equals. So I'm going to add 2 times 2, which is 4, and I end up with 3. So my b prime is going to be at -3, because we don't change the x, 3. And that makes sense because it should reflect over the line and end up on top, and it should be about 1 away. So if I were to go 1, 2, 3, sorry, from the 0, 1, 2, 3, we see that it's about 1 away from our y-axis, so it makes sense. Let's try to c now. C, we're at 1 again, so we flip the sign, which is -1, and then we add 4 to it, so we should get 3 again. So c prime should be at 0, 3. And the reason the 0 stays the same is because we're not changing the x. And if we check, once again, it's about 1 away from there. So if I go up 1, 2, 3, my c prime is in fact. So if I were to graph this, I would have c prime here, I would have b prime there, and I would have a at -3, 0, a prime. And so my triangle looks like that. And you see, we flipped it, and so A is now on the other side of the line, and B and C are also on the other side of the line than their original counterparts. Let's take a look down here. Here I have x equals 1. So when x equals 1, that means that my line is here. Okay. So I have that line. And so now A, B, and C better end up on the other side of the line when I'm done. So once again, we're doing the same style. We're taking whatever number they gave us, we're going to multiply it by 2. In fact, let's write a multiply by 2 so we know how much that we're going to add to the opposite sign. So in this case, we're going to add 2. Okay? So if we take a look at A, my current x is -3. So if I flip the sign, that means it becomes a +3. And then I need to add 2. And when I do that, I get 5, and then I leave the y alone because my y is not going to change because I'm not reflecting over an axis that is x-axis or an x value. So I end up with 5, 4. Let's do it for b. My current is -3, so I change the sign to +3. I'm going to add 2, and so it is also 5. So b prime should be at 5, 1. And that makes sense because it's in line with A and B, so it should have the same x value as A prime. C prime, well, luckily I don't have to worry about the sign because it's 0, but I add 2 and I get 2. So C prime should be at 2, 1. And so if I graph all these, we see C prime is going to be 1, 2, 1. So there's C prime. B is going to be at 5, 1, so 1, 2, 3, 4, 5, 1. So there's B prime. And A prime is going to be at 5, and then 1, 2, 3, 4, A prime. And so you see my triangle mirrors my other triangle. And that is how you reflect when you're given a equation.